Okay, so we will start again. Okay. Are you able to hear me? Am I audible, everyone?
Ma'am.
Yes.
Yes, ma'am.
Okay. So let's start with your. We have done the your what we did. Oh yes, turbidity we have done. Okay. So I hope you have got the basic idea about your turbidity. Okay. So now the second one is your color. Okay, the next one is your color. So let's see what imparts your color. Okay, I am marking the sentences. You write down those sentences in your copy. Okay, so see, dissolved organic matter from decaying vegetation, okay, or some inorganic materials such as colored soils, etc., may impart color to the water. Okay, so I am cut. The lines are being cut. Picture is a little bit lazy. From here to here. Okay. So what is told here is that the dissolved organic matter, okay, some dissolved organic matter from decaying vegetation or some inorganic materials, okay. So all these things, the decaying vegetation or the inorganic solids like what colored soils, etc. Those things it might impart color to the water, okay. And sometimes some excessive growth of what algae and aquatic these microorganisms, okay. So those things also it imparts, sometimes it imparts color to the water. Okay, so how the presence of color, it might not affect you, it might not be harmful, but yeah, it is you cannot use that water. Okay, sometimes because what happens when you wash your clothes or something, those water it might leave some impact on your clothes. Okay, the clothes it might get colored. Okay, so for all those things, and also we obviously we people we don't like to drink colored water. Okay, so for all those things, the color it should be measured. How much color it is measured in your water sample. So the color of it can be detected by your naked eye.
Octopus.
Yeah, please mute your wrong comma. Please mute your mic.
इनका रिप्रोडक्शन अच्छा है ना दो रखले दो 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 बच्चे खा
Wrong comma. Can you please mute your mic?
पता नहीं बात ना हम लोग कैसे रहेगा मेरे सामने तो मत करो डिनर में तो हाँ ये
Okay, so I have to mute you. just a second. Give me, okay? Just a second. Just wait. Yeah, sorry, I just had a call. Okay. So what I was telling is that the color of water, it can be obviously it can be detected by the naked eye, because if a color is, it is green or something, it's not colorless. So it can be detected by your naked eye. Okay. But to measure the color, we can compare. We have one apparatus, or you can say one tube. The name is your Nestler's tube. You see here, this one. It can be measured by comparing the color of water sample with other standard glass tubes called Nestler's tube, containing solutions of different standard color intensities. Okay, so what it is told is that one, Nestler's tube is there, and there are many colors. Okay, there are many standard colors present in that Nestler's tube. So you have your raw sample, okay, the colored sample you have, and you can just compare it in the with the Nestler's tube. Okay, so suppose you have your raw sample, the color is somewhat of a greenish type. Okay, so in that Nestler's tube, there will be many colors. Okay, there will be many colors, and you can compare your green color to that, in that Nestler's tube green color. Okay, so in that tube, it will be written that this is your green color, and this is your, this much of color it is present. Okay, like that you can compare. And for, in your color, for precise, you can say, for accurate determination of measurement of color, one apparatus is there, and the name is your tintometer. You see, this is your tintometer. Okay, for precise determination of small color intensities, compact instrument properly lighted from inside, called tintometer, is used generally used. Okay, and for your color, like for your turbidity, we have learned that the standard unit, it is in silica scale. Let's see what scale is used in color. So the standard unit of color is that which is produced by 1 milligram of platinum cobalt dissolved in 1 liter of distilled water. That means for your color, your measurement is done with the platinum cobalt scale. Okay, platinum cobalt scale. You have to remember. Okay, for color, the scale is your platinum cobalt scale. Okay, and the permissible color, the maximum permissible color for domestic supplies is 20 ppm. That means the permissible limit which the government has suggested, that this much of color, if it is present, it is, drinkable. Okay, so that is the 20 ppm. If it is present, then the water, it is drinkable. It can be used for your drinkable purpose. Okay, so this much is about your color. So you can write it down. Okay, so from here to here, up to here. Sorry, it again went. I think you have taken the screenshot, right? So you write those lines, okay, which I have marked red. You write those lines. Next is your taste and order. Taste and order. So let's see this one. So for so for taste and order, you see the dissolved organic materials, okay, or the inorganic salts or the dissolved gases may impart taste and odor to the water, which generally occur together. So that means your taste and odor, it goes hand in hand. Okay, these two are inseparable. Okay, these two occurs together. So what causes your taste and odor? The dissolved organic materials or the inorganic salts. Okay, or the dissolved gases. So let's see what are these dissolved gases and dissolved organic materials. Okay, so dissolved gases such as hydrogen sulfide, methane, carbon dioxide, oxygen, etc. Okay, combined with organic matter and mineral substances like sodium chloride, iron compounds, carbonates and sulfates of other elements, okay, and phenols and other dairy or oily matter, especially after chlorination. Okay, so so you see these are the dissolved gases are your hydrogen sulfide, methane, carbon dioxide, oxygen, combined with your organic matter, and mineral substances are also present like your sodium chloride, iron compounds, carbonates. Okay, all these things are present, and this causes your water, raw water, for bad taste and bad odor. Okay, very smelly. So, how can you measure the taste and odor? Okay, how can you measure the taste and odor? So, there is one term. The term named is threshold odor number. You see the threshold odor number. So, what is written? The extent of taste or odor present in a particular sample of water is measured by a term called odor intensity, which is related to threshold odor. Okay, so the threshold odor or the threshold odor number. So you see threshold odor number, there is one formula. So what is your threshold odor number? We will see that one. Okay, just wait. I will write one formula for you here. I am representing the threshold order number as TON. Okay, TON is equal to A plus B divided by A. Okay, so you see, I am writing this formula. There is no such, it's not A plus B is not written in your book. Okay, I am just giving you for your own knowledge purpose. So you see A plus B whole divided by A. So what is A? A is your raw sample. A is your raw sample. What is B? B is your diluted water or diluted sample. That means, you see, suppose you are taking you are taking a sample that is very, smelly, or it has a very bad taste. Okay, so you are taking that sample and you are adding distilled water, or you can write it here, or distilled water. Okay, distilled water. So you see, as you are in A is your raw sample. So you are taking the raw sample which is very odor or it is very smelly or very bad taste it has. So you are taking that water and you are adding distilled water to it. Okay, to when up to you will add your distilled water to such a time so that the bad smell or the taste, obviously you will not taste it, but the bad smell, the bad odor, it disappears. Okay, you are taking in a two glasses, you are taking one in one glass in you have the bad odor and bad taste water, raw sample you have, and in the other glass or in the other bottle you have your distilled water. So in that smelly sample you pour your distilled water to such an extent that your raw water which was smelly, it slightly becomes, does that smell, it disappears. Okay, so that is your A plus B. So when again you divide it by your raw sample, okay, so that gives you your threshold order number. Is it clear to you? I guess it is clear. I will give you one small calculation. You quickly calculate and you tell me what will be the answer. Okay, I will give you one. Wait. Okay, suppose I am giving you. Um, uh, I will write it. Just wait. You find out. I will see if you have understood or not. Have you written this formula? Please take screenshot or you take this one. This is A plus B whole divided by A. Okay, not B by A. It is A plus B whole divided by A. Please take a screenshot. I will just grab it. I can write it here. Just wait. Huh? I hope you can see my screen. So if I give you a question like this for 1 mark, okay, if 40 ml of water is diluted to make 200 ml to the till it just loses its taste or odor, what will be the threshold order number? If a question comes like this, so can you just tell me what will be your threshold order number? Please quickly find and tell me what will be the threshold order number.
1.2, ma'am.
1.2? No, no, it's not 1.2.
Ma'am, 6.
6.
6. I have to see and calculate. Just wait. Any other answer? Yes. 6. 6 is your threshold order number. So you got 6. So 6 is your threshold order number. Okay. So like that, you find your. So if by chance if someone has not understood, I will do it. Just wait. We have the formula A plus B divided by A. So A is what? Your raw sample. So here 40 ml of water, it is your raw sample. So 40. Okay. Then plus we are doing, we are making it diluted. Okay. So diluted, that means up to 200 we are making it diluted. So 200 is your dilution sample, and again we have to divide it by the raw sample. So like this you will get it to be 6. Okay. So 6 is your threshold order number. Like these questions for 1 or 2 marks it might come. Okay. You remember this, or you take a screenshot, or you later you see the video. Okay, in your ERP. Okay, chalo. So this one is done. Here in book it is some mistake is done. Okay. Here actually this question only I have given just now. 40 ml and 200 ml is given, but the answer it is written here 5, but it should be 6. Okay. So here for public supplies, see here. For public supplies, the water should generally be free from odor. That is, the threshold odor number should be 1 and should never exceed 3. This is the permissible limit. Okay, you should remember. For public supplies, the water should, the threshold odor number, it should be 1 and it should never exceed 3. Okay. Next is your temperature. Next is your temperature. So temperature, you see, why some temperature it is already given. Okay, that it is mentioned that for potable waters, this temperature is desirable. Okay, it is already given. So why temperature is important, because in a sample of water, or in water, you know every 10-degree increase in temperature, what it does, it affects the biological, or you can say it affects the biological activities. Okay. So every 10-degree increase also increases your biological activities in water. Okay. So your temperature is important. So how much temperature is important, you see, it may be mentioned for potable waters. Temperatures of 10 degrees Celsius are highly desirable, while temperatures above 25 degrees Celsius are considered objectionable. Okay, so you can write this line. Okay, so it is told that 10 degrees Celsius of water, it is highly desirable, and above your 25 degrees Celsius, it is not required. Okay, it is not considered. So next is your specific conductivity of water. Okay, so specific conductivity, it gives the measurement of how much salinity or how much dissolved salts you are having in your water. Okay, it gives the measurement of your salinity. Okay, so it's written here, you see, it's written here, the total amount of dissolved salts present in water can be easily estimated by measuring the specific conductivity of water. Okay, so it gives the total amount of dissolved salts, or you can say the salinity. So it is written also the specific conductivity of water. Oh, my battery is running low. Okay, so it's also written here. The specific conductivity of water is determined by means of a portable ionic water tester. Okay, so there is one certain device named as your ionic water tester, and it is expressed in micromoles per centimeter at 25 degrees Celsius. Okay, the unit is micromoles per centimeter at 25 degree Celsius. Okay, so what is mho? Mho, it is written here. Okay, mho is the unit of conductivity and equals to 1 ampere by 1 volt. Okay, it is all these things you got in physics, this ampere, volt, all these things. Okay, so the specific, the specific conductivity uh, that you got that in your in micromoles, okay, at 25 degrees Celsius, it is multiplied, okay, it is multiplied by a coefficient that is your 0.65. 0.65, it is multiplied with the micromoles that you get in your conductivity to get the dissolved salt content in milligrams per liter or ppm. So whatever value you get using your the conductivity, whatever value you get at 25 degrees Celsius, what you do, you multiply it by 0.65, a coefficient it is already mentioned. So you multiply with 0.65 and you get your the dissolved salt content in your raw water in milligram per liter, or you can say ppm, parts per million. Okay, so this five is all about your physical characteristics of water. Okay, so you have known today the physical characteristics. These are easy, and the things which I have marked it down. These are the important points. So you can note it down in your copy. Okay. So then next is your chemical characteristics of water. But today I don't think I can start chemical characteristics. I'm very much tired. Two the classes already taken. So chemical characteristics also we have many points. Okay, we have many points like you see here: total solids and suspended solids. Then we have pH. Okay, then we have hardness. Okay, hardness we have. Then we have your next. Let's see what's there. Nitrogen content. Okay, so many things are here, and the most important things is that these are very simple. Okay, chloride content, all these things, very simple things are this. Just you need to know the permissible limits. Okay, up to what limit your chloride should be present, up to what limit your hardness should be present, up to what limit your nitrogen content should be present. So the if you remember the permissible limit, I think the other things you know only, then you can easily write your own sentences if in exam also it comes. Okay, that's not a very hard thing. So next class we will deal with your chemical characteristics of water. Okay, chemical characteristics we will deal in the next class. Okay. So let's and wind it up here today. Let me take the attendance. Roll number 1.
Ma'am.
Okay. Roll number 2,
Yes, ma'am.
3,
Present.
4,
Present, ma'am.
5, 6, 7, 8, 9,
Present, ma'am.
9, 10,
7
11,
present.
7 present.
Yes, ma'am.
Okay. Then your what was that? Roll number 11, 12, 13,
Yes, ma'am.
13, 13
Ma'am, 12 present.
okay, 12 present, 12, 12, 12, okay. 13
Ma'am, 13.
present, okay. 14,
Uh,
roll number 14, Gyani is absent, Gyani Zamatia, okay. 15, 16, 17, 18,
Yes, ma'am.
19,
yes, ma'am.
20,
Ma'am.
20, Howbam is present, okay.
Present, ma'am.
Yes. Then 21,
Yes, ma'am.
22,
Yes, ma'am.
23,
Yes, ma'am.
24,
Yes, ma'am.
25,
Present, ma'am.
26,
Present, ma'am.
27, 28,
Yes, ma'am.
29, okay to,
Yes, ma'am. Yes, ma'am.
okay, 30,
Present, ma'am.
31, 32,
Present, ma'am.
33,
Yes, ma'am.
33 is present, Jodha Asen,
Yes, ma'am. Present.
okay,
Yes, ma'am. Present.
okay, 34,
Yes, ma'am.
35, 36,
Present, ma'am.
36, Jesh Kumar, okay,
Yes, ma'am.
37, 38, 39, 40,
Yes, ma'am.
41,
Present, ma'am.
42,
Absent.
43,
Yes, madam.
44, 45, 45 present.
Yes, ma'am. Present.
Okay. Deshan. What Desahini. Okay, Desahini.
Yes, ma'am.
Okay. Then 46,
Yes, ma'am.
47,
Present, ma'am.
48, 49, 50. Okay, now I will read out the absent ones. Okay, just listen and tell me if anyone is left out. 5, 6, 8.
Yes, ma'am.
Okay. Then 10, 11, 14,
11.
15. Yes?
Ma'am, 14 present.
Okay, 14 present.
11.
11. Okay.
Ma'am, 13.
13. 13, yes, I have given present. 15, 16, 17. Then your 27, 31, 35, 37, 38, 39, 42, 44, 48, 49, 50. Okay, so others I have given present. Today 2 classes we have taken. Okay then, you take a rest a bit. After that you have the third class. Okay, roll number 11. Sanin, I have given you present, I guess. Let's see. Sanin is present. 11. Oh yes, I have given you present. Okay then. We will see you in the next class. Okay.